Alright, 7.5. Apply the tangent ratio. Couple vocab terms to start. A trigonometric ratio is a ratio of the lengths of two sides in a right triangle. There are actually three trig ratios I'm going to have you learn in this unit. The first one is called tangent. The ratio of the lengths of the legs in a right triangle is called the tangent of the angle. This is also, I'm going to more commonly call this opposite over adjacent, as you'll see. We'll do some examples and it'll make more sense then. But this is the definition. If triangle ABC is a right triangle with acute angle A, there you go, this side is opposite A. The side that does not touch the angle is the opposite side. Of course, the longest side is the hypotenuse, and the other adjacent side is going to be called the adjacent side. So tangent, if you're referring to the tangent of A, it's going to be the opposite side over the adjacent side. So in this case, BC over AC. I'm sorry, AB. Okay. Alright, so for example, let's say we're trying to find tangent of S. Tangent of S is the opposite over the adjacent. The opposite side is 60, the adjacent side is 25. I can simplify this. Actually, you know what? I think they probably want us to do this first. Alright, opposite side is RT. The adjacent side is ST. There we go. RT is 60. ST is 25. If I divide both of these by 5, I get 12 over 5. 12 over 5, that's about, I think it's 2.4. Yeah, 2.4. Okay. Let me change colors. Now, when dealing with angle R, the side opposite angle R is 25, and the side adjacent to angle R is 60. So we've got ST over RT now, 25 over 60, which is 5 over 12. And if we pull out the calculator, divided by 12, 0.4167-ish. Okay. Alright, let's go on to page 2. I'll let you guys do this checkpoint. Example 2. Find the value of x. Okay. Tangent of 31 degrees, we already know, is the opposite over the adjacent side. So in this case, 17 over x. Okay? Actually, I think they wanted you to do this first. So, opposite over adjacent. And we know that the opposite side is 17. The adjacent side is x. There we go. Okay, I'm going to multiply each side by x. Okay, and I'm going to divide each side by tangent of 31 degrees. Okay. Use a calculator to find tangent of 31 degrees. Now, you actually need a special calculator for this one. This one won't work. Let me pull up this. There we go. So, tangent, actually, let me make sure it's in degrees. There we go. So, tangent of 31 degrees, 0.6009. Okay, so I've got 17 over 0.6009. If I divide that, 17 divided by 0.6009 0.009. 28.3, I'll say. Alright. Okay. Find the height h of the lighthouse to the nearest foot. Okay, so here, if we're looking for the tangent of 62 degrees, it's opposite over adjacent. Okay, so we're writing the ratio for tangent of 62 degrees. Tangent of 62 degrees actually, let's do that at the end. So tangent of 62 degrees equals h over 100. I'm going to multiply each side by 100. So now I have 100 times tangent of 62. Alright, so 100 times tangent of 62 degrees, 188.07. I'll say 188.1. Nope, not degrees, sorry. There we go. And this would be in feet. Okay, let's go on to page 3. Alright, in this case, we're going to use a special right triangle to find the tangent of a 30-degree angle. Okay, so it doesn't tell you what kind of 30-degree angle. Any 30-degree angle will work. We know, hopefully you guys remember, that in a 30, 60, 90 triangle, the long leg is root 3 times the short leg. So just to simplify things, I'm going to choose root 3 as the length of the shorter leg to simplify calculations. Okay? The longer leg is the shorter leg times root 3. So x is root 3 times root 3, which is 3. Okay, so this is 3. If we're looking for tangent of 30 degrees, that's going to be the opposite over, oops, they want us to write out the ratio again. You don't have to do this in your actual notes, but they want it in here. Opposite over adjacent. Root 3 over 3. Okay? And if you plug this into your calculator, oops, there we go. Plug this into your calculator, you get 0.577. Now, add another one. 0.5774. Alright, you guys can do the checkpoint, and that's all.